One thing you might have noticed when you look at your periodic table is that all of the atoms, all of the elements in group 1 have an ion charge of +1, and all of the elements in group 2 have an ion charge of +2. So, and then if you skip across all the elements in the middle over to the nonmetals, you'll see a similar pattern. In fact, the periodic table you get in grade 11 doesn't even have ion charges on it, because you can tell just by looking at what group the element is in. However, you probably noticed that the elements in the middle, those metals, some of them have multiple ion charges. And another word for those is the multivalent metals. Multivalent, meaning they can have more than one valence shell configuration as an ion. The reasons for that will become more apparent in future chemistry courses, but just think of it like they can lose different numbers of electrons and still be stable, or at a low energy. So iron is an example. Iron, you'll notice, could be +2 or +3. When you write the name, or you see the name and you see the Roman numerals in the middle, those Roman numerals tell you what the ion charge is, or the combining capacity is. It's another word for it. So if this says iron Roman numeral 2 bromide, that tells me this iron is +2. And then I carry on just like I did before. So iron was +2 in this case. Bromide is still -1. You can see it's going to take me 2 bromides to make a -2 to cancel out the +2. So my formula would be FeBr2. Right? This is one bromide, this is another bromide. 2 bromides for every 1 iron ion. Okay, let's do one more. Chromium 6 oxide. Chromium +6. Oxide is always -2. Okay, well in this case, to get the ion charges to balance, I'm going to need 2 more oxides. That will add up to -6. So 1 chromium for 3 oxides, my formula would be CrO3. And the last type of ionic compound that we're going to look at are those that contain polyatomic ions. Polyatomic ions, these are groups of atoms that tend to stay together, and they have a charge, which is why they're called ions. You'll find a list of them in your data book. How to recognize them if you see the name is the end does not end in "ide." So if I see sulfate or sulfite, that tells me it's a polyatomic ion, and I should check my list to find out the formula for it. Okay, so iron Roman numeral 2 tells me this is iron with a +2 charge. Having recognized that sulfate is polyatomic, and I check my list, I see the formula for sulfate is SO4, and the charge for sulfate is -2. And I treat it as if it's just a single element. I do the problem exactly as you did before. +2 and -2 cancel out, so my formula here would be FeSO4.